Hi there, welcome back. Well, we've made some progress. I took the radio out of the chassis, put it on the stand and started working on it. And let's start from the first stage. Right, first things we have is we have all the switches working. If you recall, those switches weren't catching. All that took was some oiling, lubrication, and I've got all the function of the switches working. A lot of contact cleaner and WD-40 and so on, so those are fine. Next, I went and started on getting the power supply line checked, and that seems to be in order, with very few exceptions. I think some of the solder joints were a bit iffy, so I refreshed some of those. But other than that, the components on the power supply section seem to be fine. The filter capacitor over here, it's a two section. It says 40 microfarads. The schematic actually says 50. That was checked. It seemed to be okay. I did a bit of reforming with the capacitance leakage tester reformer, which I built. I'll link that above. And we seem to have that working okay. Then everything that was on the output stage was checked and capacitors replaced. The pile is getting quite interesting. If you can see this one was leaking really badly. I checked all of them and they're all leaking really badly. So I'm glad I changed that first one, that coupling cap, to the grid of the output tube before I tested it. Now, one thing I found quite interesting is these aero caps are actually shielded capacitors. If you see here, you've got the two connections, the two outlets. You've got the two pins on there, two wires on there. Then you've got one here which is soldered to the shield, and that is indicated on the schematic. I'll show you that in a second. So I had to make some of those. Now, these shielded capacitors are actually used in the low-level audio. So this is the first one that comes from the switch that selects either radio or pickup, and the signal comes over there, and then you've got the shield on the outside connected to ground. That was the first one I've done, and here's the second one that also is on the low-level audio going into the preamp, and what that does is just helps to reduce noise pickup. Now, I've done a video on making these. What I've used in this particular case is a slightly different technique. I used copper tape, and the copper tape has the advantage that you can actually solder onto it. So you take the capacitor, you wrap it in copper tape, one continuous length of copper tape. If you have the thick copper tape, you're just going to wrap it around once. Mine is quite thin. Then you solder, you tin it, and tin a piece of wire, solder wire on there, and complete that with heat shrink, and then of course label it so you know what the hell that thing is in the future. And those things work very well. So that's the technique I've used here. As you can see, there's quite a few other caps have been changed. That's the first one I did, which I showed you before. A lot of the solder connections here were cleaned up a little bit. A couple more caps over here, down here, and across here. All these are the ones that you've seen in the junk box. There was actually one resistor. That resistor down here was open. It's a 10 megohm resistor, and that is the one that biases the preamp tube. So it was open or very high. It's supposed to be high, but 10 megs is high enough. So that was replaced. That's the only resistor I've found that's completely off so far. A couple more caps over here and one over there. Now, as you can see, quite a bit of cleaning has been going on. These tubes and the sockets were cleaned. As you can see, there's still parts here that I haven't cleaned. That's just to basically give us a satisfaction of seeing the before and after. But part of the chassis has been cleaned on that end, and also on this end. Again, that section there I still have to do. What I do is, as I go to parts of the circuit that need checking, like the output tube and the preamp, I tend to sort of start cleaning around it when I'm cleaning the tube. These tubes had very, very dirty pins, so those were brushed with a wire brush, and then the sockets cleaned with contact cleaner. So still quite a bit to do, but I'm happy to inform that we've got quite far. Let me show you the schematic. Using my usual technique of coloring in as I go along, I photographed the schematic from the original board as I showed you. Just changed the brightness and contrast in Photoshop, put it up here, and then as a PDF I can edit what I go through and what I haven't. Now the green is everything I've checked, that's all fine. The reds are where I change components. As you can see, just about every capacitor has been changed over here. There is some confusion, or I should say there's a difference between the schematic and the actual radio, and that is on the tone control. This here is a tone control. It's a 1 meg variable resistor. It's a potentiometer wired up as a variable resistor to ground. So two of the pins are soldered together, and it goes from 0 to 1 meg. Then there's that capacitance series, and they have it connected here in the schematic to the output of the preamp tube over here. It is actually connected, wired to the grid of the power tube. Now, I'm not sure whether that was a modification or an error. I wired it back, replaced the capacitor, put it back the way it was on the circuit, but I'm leaving the option open to change it later. It's just a question of where I solder this side of the capacitor. It shouldn't be a problem. I think we may have a problem in that over here we're probably going to have an impedance divider with this capacitor and that capacitor, which may actually drop the volume significantly rather than just take off the highs. But we'll see. The important thing is this whole section has been done. So the power amp section has been checked, the preamp section has been checked, and again here I've found a couple of differences between what's on the schematic and what's in fact on the radio. This acts as a detector and preamp. So it has two diodes, and there's your anode for the preamp function. So it detects the audio and then it amplifies it to send it to the power amplifier. Now this here is that first screen capacitor. As you can see, it comes off the volume control going into the grid, so you need as little noise as possible over there. And then the actual capacitor feeding the top of the volume control is also the other screen capacitor, and that comes down here to that switch. That switch switches between the pickup input when it's in this direction and the radio function when it's in the other direction. So this is all the radio section that we'll be looking at in a little while. So this preamp is done with the exception of those two lines over there. Now that's a 30 puff capacitor over there, probably RF suppression, maybe to get rid of the RF that's already on the detector section, if that is the detector section, I think it is. And there's also this line over here which goes back through a 1 meg resistor, which isn't there, and it wasn't there. It's not as if it's been removed. Comes to this point. This point over here goes down to the magic eye. It also goes across to there, and it goes across to there. So I really don't know. I really don't know why this is not there, but we'll find out. If we find a resistor lying around somewhere lonely at the end, we'll know what we'll know we've found it, maybe figure out what it's supposed to do. Now again, there's no instruction other than the schematic, but it's fairly straightforward, and what I can show you now, obviously this is the power supply itself, the transformer, and the AZ41, the rectifier tube. Everything's working fine there. But what we can show you now is we've got a direct connection. Everything's been checked from the pickup input through there. When we switch pickup, the signal goes through there, up there, through that cap to the top of the volume control. The bottom of the volume control actually doesn't go straight to ground, it goes to a 100 ohm resistor, and this point here is a feedback section from, if you follow that line, through that 100 nanofarad capacitor and a 3K resistor to the output of the speaker. So it's negative feedback. But otherwise you get a adjusted signal coming out through here, through this capacitor. There's a grid leak to ground, that 10 meg that was open. It goes into the grid and all the magic happens over there, and you end up with audio coming out over here. Now in the case of the pickup, the only magic that's happening is a preamplification. There's no detection going on. So this is a preamplifier for the audio signal, and then it goes to drive the output tube. Now I'm going to set this up and show you that indeed the amplifier, the audio section, is working quite well. Let's set it up. So here's the usual. We have 1 kilohertz signal, we have 100 millivolts RMS, and we'll activate it by switching on the channel. That signal then goes to the pickup input there, through that. The ground of the signal generator is connected to the chassis ground. I have the dummy load, I have the limiter, dim bulb limiter with 2 lamps active. You can switch that on. And now we hit the volume down, hit the pickup, so that switches it on. Give it some volume. There's 100 millivolts signal coming in, so it's not that high, but should be enough. Oh, it does help if you switch on the signal generator. There we go. And it's working. And as I thought, this is the tone control, which is actually bleeding off far too much. There's the tone on maximum. There's a bit of hum, and it could be the filter caps that probably need a bit of help. It's 40 microfarads, the circuit calls for 50s. I don't know whether this is original or whether it's been replaced. We'll check that later, but we've got ourselves a working power amp, or rather working audio section. However, that still gives us bugger all. The switches work, but nothing, no signal comes out. So the next stage obviously is to carry on back in the circuit to the RF stage and see if we can figure out what the problem is, because I get no radio, and this is a radio, not a power amplifier. Right, let me carry on.